Solve the quadratic equation by completing the square. Before we get started, let's make note of the fact that in order to complete the square, we must have a leading coefficient that is positive 1. In this video, we'll show two examples where the leading coefficient is already positive 1. But if it were not, we would need to divide both sides by some constant in order to first achieve that positive 1 coefficient and then complete the square. The idea here is that we want to create a perfect square trinomial on the left-hand side. And let's first notice that this constant is not the correct one that creates a perfect square trinomial. So our first move is going to move it out of the way. We'll just add 15 to both sides and keep both of the variable terms on the left. So we have x squared minus 6x, and we're going to leave a little bit of space here in order to allow room for the correct constant that completes the square, and in a previous video we referred to this as the magic number. So now it's time to find that magic number and write this as a perfect square trinomial on the left-hand side. And if you'll recall, the formula for determining the magic number is that we take the b coefficient, we divide that by 2, and then square the quantity. As a reminder, the b coefficient is the coefficient on the x to the first power term. So in this case, our b coefficient is negative 6. So we'll take negative 6, divide that by 2, and square that quantity, which gives us negative 3 quantities squared, which is positive 9. So 9 is the magic number. It's the value that we're going to add in here in order to create a perfect square trinomial. But anytime we add something to one side of an equation, we must also add it to the other side to preserve a balanced equation. Anything that we do to the left, we must also do to the right. So now what we've created here is a perfect square trinomial on the left, and that's going to factor into a binomial squared. On the right, we have 15 plus 9, which is 24. And let's look at this factorization on the left. A perfect square trinomial is always going to factor into x. The sign is going to match what's inside here, so that's going to be minus. And the value that we factor into here is going to be what we had before we squared that quantity, finding the magic number. It's essentially the square root of the magic number, so we have minus 3 in the factorization. And now let's recall we're trying to solve for x, and what we have is a quantity squared in terms of x. And in order to isolate this x, the next thing that we're going to do is to take the square root of both sides. So when we take the square root of both sides of an equation, that square root comes along with a plus minus, and the plus minus goes on the constant side, not the side with the variable. The square root of a quantity squared, these two operations cancel each other out, and we're left with x minus 3 on the left-hand side and plus or minus the square root of 24. Let's notice that the square root of 24 can be simplified. If we factor 24 into the product of 4 and 6, we can split a radical over multiply, so the square root of 24 becomes 2 times the square root of 6. So in our next step, let's just replace rad 24 with plus or minus 2 square roots of 6. Now the last thing that we need to do in order to solve for x is to simply add 3 to both sides. So the 3's cancel out on the left. We have x is equal to 3 and 2 rad 6's are not like terms, so they cannot be combined. So we'll just have to write them down separately. 3 plus or minus 2 square roots of 6. And these are the two solutions for this quadratic equation. Now in order to check this answer on our calculator, we're going to plug in 3. Now we can only check one at the time, so we'll just do plus 2 radical 6. The radical is right here, so we're going to have to hit the second button in order to access it. And then we'll plug in 6, come out from under the radical, and then select store, and we'll store that quantity into x and hit enter, and that's going to make that value easier to work with. Now we go back to the beginning equation, and we're going to just type it exactly as we see it. We'll type in x squared minus 6x. Remember, we've stored our solution into x, and then minus 15, and hopefully that gives us 0 on the other side. And then we could do this again for the other solution, 3 minus 2 radical 6, but both of them are going to work. Let's see that one more time. We're going to solve for x by completing the square. We'll notice first that this number here is not the magic number. This is not a perfect square trinomial. And so our first move is going to take that constant to the other side and make space for creating a perfect square trinomial on the left. The 2's cancel out. We have x squared plus 8x. We leave space for that magic number, and then we're equal to 2 on the right-hand side. As a reminder, that magic number formula is b divided by 2 quantity squared. In this case, our b coefficient is 8, so we're going to have 8 divided by 2 quantity squared. 8 divided by 2 is 4, and 4 squared is 16. So 16 is the magic number that needs to be added to the left-hand side to create a perfect square trinomial, but we also must add that to the right-hand side in order to preserve the balance of the equation. So now, this is a perfect square trinomial on the left. It should factor into a binomial squared, and on the right-hand side, let's just combine that to be 18. The factorization on the left is that we have x. The sign is going to match what's inside here, so it's going to be plus, and the constant is going to be the square root of the magic number, which is in this case 4. And if that's hard for you to determine, you can always look back here to see what that square root of the magic number was. Now we take the square root of both sides, and when we take the square root of both sides, it comes along with a plus minus, and the plus minus goes on the constant side. On the left, the square root of a quantity squared, these operations cancel each other out, and what remains is x plus 4 on the left-hand side. Then we have plus or minus square root of 18, and let's take a look at that quantity. Square root of 18 does reduce because it factors into 9 times 2. We can split a radical over multiply. The square root of 9 is 3, and the 2 would stay then under the radical since its square root is not an integer value. So let's now replace plus or minus square root 18 with plus or minus 3 rad 2's. And the last thing that we need to do is to subtract 4 from both sides. Since 4 and 3 rad 2's are not like terms, we can't combine them, so we just write down both quantities. We have negative 4 plus or minus 3 square roots of 2. And these are the values of x that would plug into the original equation to make a true statement. Now let's also check our solution to the second equation. Again, we're going to store our solution into x. So we say negative 4. Let's start with the plus 3 radical 2 solution. We'll come out of the radical and then store that quantity into x to make it easier to access when we're checking. And then again, we go back to the beginning equation and type it in exactly as we see it. So that's going to be x squared plus 8x, remembering that our solution has been stored into x, and minus 2, and we hope this is equal to 0. So the positive solution works. We could do this again for the negative solution. One trick I want to show you is that you can copy paste something that you already typed in by just arrowing up until you're highlighting what it is that you want to copy. And then if you hit enter, it will paste that down into the working field. Then I can come over here and just change it to a minus and then hit enter to store the other solution into x. And then again, I can just go up, 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 up until I'm highlighting what it is that I want to copy. I'll hit enter to bring it back down to the working field. And then now I'll hit enter again to evaluate our equation, but now with this new value stored in for x. So I hit enter. And this time we get something strange as an output. Let's take a moment to discuss what that means. So when our calculator says 1e negative 12, that's the calculator syntax for scientific notation. So what this means is 1 times 10 to the negative 12 power, which is essentially 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 decimal points. So we move our decimal 12 places to the left, and this quantity is really, really small, approximately equal to 0. Sometimes the TI calculators will give us this quantity here, which is very, very close to 0 when it means to say 0. This is due to a floating point error, and that's a topic for another video. But what we'll say here is that we were expecting the output of this equation to be 0 when we plugged our solution in, and what we got was this value that is super close to 0. But we need to understand that the calculator does mean 0 when it's saying this. This is a programming error that sometimes occurs. And so the big takeaway is here that both of our solutions do actually work.